7th grade, Module 1, Unit Review. Directions: make sure you answer the following questions fully and completely. You must show all work, even things you put in the calculator, and not receive any points for each question. Right? It's open notes, it's individual. This is just like what your unit test will look like. Right? This is just like what your unit test will look like as well, with those same directions. So make sure that you're writing stuff down. No work, no points. So you need to make sure you're showing your work. Okay? So number 1 says a recent study claimed that in any given month, for every 9 hours a boy spent studying, a girl spent 12 hours studying. Is the relationship between the number of hours studying by boys proportional to the number of study hours by girls? Explain your reasoning. So the question is this proportional? The answer is yes. Yes, this is proportional. And so why is it proportional? Well, proportional itself means that as one thing changes, the other changes by the same amount each time. So if we look at this and we're to make like a table really quickly on this, right? And we say that for the boys compared to the girls, okay? Every time that a boy studies for 9 hours, the girl would study for 12. If the boy studied for 18 hours, the girl would study for 24. All right, if the boys studied for 90 hours, then the girls studied for 120. And so you'll notice that with each one of these, this is my given ratio or rate, right? Given ratio, given rate, right? Meaning it's given to me in the problem. 9 hours for a boy, 12 hours for a girl for studying, right? And so if I can take that given ratio or given rate and find a scale factor, and I multiply it by the same scale factor and get the same distance off of each other from before, then that means it's proportional. So case in point, 9 to 18. 9 times something is 18, or 18 divided by 9 is 2. So my scale factor here, between here to here, is a 2. And if I use the same scale factor of 2, 12 times 2 is 24. So that would be a matching scale factor. If I wanted to look at the difference between 9 and 90, when we look at multiplies, right? 9 times something is 90, or 90 divided by 9. That's a scale factor of 10. And if I use that same scale factor here, 10, 12 times my same scale factor of 10 is 120. So if it changes at the same rate, it changes by the same amount each time, you're adding a multiple of it each time, right? That is proportional. So this is a proportional problem. And then under explain your reasoning, changes, and this is shorthand obviously, but it changes at the same rate or by the same amount each time based on that scale factor, right? Number 2 says, Saturday morning, Mr. Herringer discovered he has a leak coming from the water heater. Since plumbers charge extra to come out on weekends, Mr. Herringer plans to use buckets to catch the water. He places the bucket under the drip and steps outside to play with his kids. In 30 minutes, the bucket is 1/8 of the way full. What is the rate at which the water is leaking per hour? Well, 30 minutes is not an hour, it's 1/2 of an hour. So this is also checking to see if you know what a unit rate is. Unit rate is 1, right? The number, one of the numbers comparing is the number 1. Not 1 is in it, it's the number 1 only. So not like 12 where there's a 1 in it, it has to be just 1 by itself. So 1/2 is not 1, 30 is not 1. So that's not a unit rate. But what is the rate at which the water is leaking per hour? This is my unit rate. So in 1 hour, if 30 minutes is a half hour, we know that 60 minutes would be a full hour, 1 hour. And if we look at that, if it does 1/8 in 30, 60 is twice as much, or 1/8 in a half hour, it should do 2/8 in 60 minutes, or 2/8 in a full hour. So what's my unit rate? My unit rate is 2/8 of a bucket, or we can reduce that. Divide both the top and the bottom by 2. 2/8 is the same thing as 1/4. So it's 1/4 of a bucket, or 2/8 of a bucket, but I want you to reduce if possible, per hour, or per 1 hour. Okay? So that's the rate at which the water is leaking, 1/4 of a bucket every hour. B says, write an equation between the number of buckets filled, y, in x hours. So we're just going to set it up as Yo Mama's ex-boyfriend, y equals mx plus v, right? In this case, there was nothing for our starting point. We didn't start with anything. We started with 0 water. So that would just be a plus 0, which eventually we'll just leave off, okay? And if we're looking at buckets filled versus hours, remember we fill 2/8, just kidding, 2/8, or we said here earlier, 1/4. So we want to try to use reduced if possible. 1/4 of a bucket every 1 hour, right? Every 1 hour. So y equals 1/4 x plus 0, or y equals 1/4 x. If you'd rather use the decimal instead, it'd be 0.25 x. For our buckets filled, that's how many buckets are filled in 1 hour, right? C says, what is the longest he can be away with only one bucket? If I only have one bucket to fill up, think about it, right? Draw a picture, okay? Sometimes a picture helps. We see this is the halfway mark. We see that this would be halfway in between it, or that's the 1/4 mark, right? 3/4 mark. Keep in mind, if it fills at 1/4 of a bucket per hour, this would be 1 hour. This would be another 1 hour. This would be another 1 hour. And this would be another 1 hour, right? What's the most that I could be away, right, if I only have one bucket? Well, let's see. I see 4 hours. This picture, by the way, is still showing work. This is another way to show it. You could also say, how much away is he going to be? Well, let's see. It's y equals 1/4 x, and we know that it would take 4 of these 4/4 to make one whole, right? So if we plug this in, 1 equals 1/4 times x, divide both sides by 1/4. But again, a picture works just as well, right? So if that works for you, that's easy, right? How many buckets will he need to make it through the weekend until 9 a.m. on Monday if he discovered the leak and started using the buckets at 9 a.m. on Saturday? So this is where we need to know some stuff. We see it's 9 a.m. to 9 a.m., so that makes that easy, right? It's a full day Saturday. It's a full day Sunday. And since it's from 9 to 9, that means we're not doing anything other than full days, right? So from 9 a.m. Saturday to 9 a.m. Sunday is one full day. From 9 a.m. Sunday to 9 a.m. Monday is a second full day. So that's 2 full days, right? Keep in mind each day is 24 hours. So if it's 2 full days, it should be 48 hours, right? If there's 48 hours for dripping, and we know that each bucket fills in 4 hours, all we have to do is divide it. 48 hours divided by each bucket is 4 hours. We'll find out how many buckets we need. 48 divided by 4 is 12. We need 12 buckets. 12 buckets. Okay? 12 buckets is what we need. Give me 1 second here, because I don't think it's going to slide it with it. We'll find out. Nope. All right. Last one here says, a photographer takes a photo of a field on which a circular crop area has been planted. He prints the photo out and notices that 5 centimeters of length in the photo corresponds to 10 meters in actual length. So part A says, what is the scale factor of the actual farm to the photo? Right? So again, drawing a picture can help. Okay? So if you take a photo on a field, right? He prints the photo out. He notices that for every 5 centimeters of length, every 5 centimeters of length is really 10 meters. So if we take out, for just a moment, if we take out units, what is my scale factor? Well, it's going to be 5 times my scale factor that'll equal the 10. 5 times some number is 10, or the other way to do it is work backwards. 10 divided by 5 is 2. My scale factor is going to be a 2. Sorry, I drew that picture a little early. That's for the second part, which we'll just draw over here. So second part says, part B says, if the photo dimensions are 25 centimeters by 20 centimeters, what are the actual dimensions of the field in meters? So it's 25 by 20. Okay. So if the photo is 25 by 20, these are centimeters. These will obviously be meters. Okay. We know that my scale factor is 2. So if I take each of these, multiply it by my scale factor, and put it back where it's supposed to be, I will have that info. So 25 times 2 is 50. This is 50 meters. And 20 times 2 is 40. This should be 40 meters. Okay? Using our scale factor to scale it up from the picture to the actual. Okay?